Hello everyone. So let us proceed to factors affecting van der Waals forces. So there are three factors affecting van der Waals forces, and the factors are molecular size, molecular shape, and molecular polarity. Okay, so that means if you have two molecules, let's say molecule A and molecule B, and you want to determine sama ada molecule A atau molecule B yang ada stronger van der Waals forces, you have to look at these three factors. Okay. Tapi di sini ada cara dia. Factors ni mesti kamu tengok one by one, iaitu step by step. That means in order to determine sama ada A or B yang ada stronger van der Waals forces, first you have to compare the molecular size of A and B. If the molecular size of molecule A and B, the molecular size is the same, that means you have to proceed to the next factor. Okay, kalau molecular size dia sama, baru tengok molecular shape. So let's say lah shape A and B pun sama. Baru tengok the last factors iaitu molecular polarity. Okay, so yang polar akan jadi lebih kuat dia punya van der Waals forces compared to yang non-polar. Okay, tapi let's say lah when you look at the molecule of A and B and the molecular size dah lain, maksudnya the molecular weight dia dah berbeza. Okay, so that mean you can just determine the strength of van der Waals forces from the molecular size. Tak perlu nak tengok shape, tak perlu nak tengok polarity. Okay, tapi another condition, another possible keadaan adalah apabila molecular size of A and B sama, molecular weight dia sama, tapi kamu tengok molecular shape dia lain. So, the molecular shape can be used to determine the strength of van der Waals forces. Tak perlu nak pergi tengok polarity. Okay, so let us look at the first factor iaitu molecular size. Okay, so in order to explain this molecular size, I will use this example here. Okay, so in this example, saya guna group 18 noble gases. Okay, and then noble gases to start from helium up until radon. Okay, so maksudnya ini going down the group in group 18 lah. Okay, and going down the group 18, you can see the boiling point makin meningkat. Okay, so boiling point increases. So kenapa? Okay, so let us look at the explanation here. The boiling point of the noble gas increases down the group. This is because as we go down the group, the number of electron increases. Okay, betul? Or if you don't want to use this sentence, you can use going down the group, the molecular weight increases. Okay, ialah molecular weight makin meningkat, and then as a result, the atomic radius also increase. So atomic radius makin besar. So going down the group, size makin besar. So what happen bila size dia makin besar? So the distance over which electron can move increases. So maksudnya kawasan elektron tu boleh bergerak makin luas. Okay, the easiest example you can see here, I draw the neon. Okay, neon dengan krypton. Okay, so let's say neon since dia predictable dekat atas, that means dia punya size is smaller than krypton. Okay, so krypton is bigger lah. Alright, so the distance over electron can move in krypton is bigger compared to the distance over electron can move in neon. Okay, so kenapa kalau distance over which electron can move bigger? Kenapa? Okay, so because bila elektron tu kawasan elektron tu boleh bergerak lebih luas, that means the temporary dipole yang akan terhasil akan lebih besar. Okay, bigger possible temporary dipole. For example, neon, this is the temporary dipole, and krypton ada temporary dipole yang lebih besar. Okay, so bila dia ada temporary dipole yang lebih besar, the strength of dispersion forces increases. Okay, so dispersion forces ataupun London dispersion forces tu makin kuat. So, more energy is needed to overcome the attractive forces. Okay, so kalau kita nak boil something, we need to break the bond between the molecule. So let's say bonding between krypton dengan another krypton. So we need to break the bond between krypton tu. Okay, so nak break the bond, since the bonding is strong, that means you need more energy ataupun more heat energy lah. Okay, more energy in the form of heat. So as a result, bila banyak heat energy, so maksudnya dia punya boiling point akan makin meningkat bila attractive forces tu makin kuat. Okay, so the important point here adalah the bigger the molecule, that means the van der Waals forces is stronger. So strong van der Waals forces need more energy to overcome the attractive forces. So higher boiling point. Okay, so the next factor affecting the strength of van der Waals forces is molecular shape. Okay, tapi saya ingatkan balik, kamu akan tengok the second factor ni apabila the first factor iaitu molecular weight dia sama. Molecular weight antara molekul yang kamu nak bezakan tu sama. Then baru tengok molecular shape untuk determine the strength of van der Waals forces. Okay, and then molecular shape is important in determining the strength of van der Waals forces for isomers in organic compound. Okay, so molecular shape ni penting untuk determine strength of van der Waals forces untuk isomer. Okay, so what is isomer? Isomer adalah two or more compound with the same formula but a different arrangement of atoms in the molecule. Isomer ni adalah dua atau lebih compound yang chemical formula dia sama. Maksudnya kalau dia bilangan karbon, bilangan hidrogen, and kalau dia ada oksigen, bilangan karbon, hidrogen, oksigen dia sama untuk kedua-dua atau lebih compound tu. Kiranya semua compound tu ada bilangan karbon, hidrogen dan oksigen yang sama. Okay. Alright, so example yang paling senang adalah dekat bawah ni lah. So, dekat example ni saya guna pentane. Okay, siapa yang belajar organic chemistry, dia tahulah pentane adalah organic compound yang ada 5 carbon and 12 hydrogen. And then the next structure adalah isopentane. Isopentane ni pun bilangan karbon dan hidrogen dia sama. Cuma dia bentuk arrangement of carbon and hydrogen dia tu lain. Okay, and neopentane pula carbon dan hidrogen pun sama tapi arrangement dia tu lagi pendek, dia lagi banyak branch. Okay, so itu yang dimaksudkan. So kiranya betul lah, tally lah dengan apa yang saya beritahu kamu. Kalau bilangan carbon and hydrogen dia sama, so maksudnya we cannot use the first factor to determine the strength of van der Waals forces sebab dia punya molecular weight dia, since bilangan carbon and hydrogen dia sama, so molecular weight dia sama. Okay, same molecular weight. That's why we need to look at the molecular shape. Okay, untuk molecular shape, you don't have to worry. Kita tak guna shape yang complicated. Kita just akan guna long and linear molecule atau short and branch molecule. Okay, so this one can be categorized. Ini pentane, ini pentane. So this one pentane, since kamu pun boleh nampak the shape is long and linear. So inilah long and linear. Okay, and yang hujung ni dia lagi banyak branch. So ini kita panggil dia short and branch molecule. Okay, so short and branch molecule. Alright, yang ini, yang tengah-tengah ni dia nak kata panjang sangat tak, nak kata dia pendek sangat tak. Dia ada branch tapi tak banyak sangat. Okay. Alright, so dia kata long and linear molecule can develop bigger temporary dipole due to larger contact surface area. Okay, so this long and linear molecule, dia ada contact surface area yang besar. Means, antara pentane dengan another pentane, contact surface area tu besar. Okay, so dia ada bigger temporary dipole and then area untuk berlakunya attraction ni pun besar, kamu boleh nampak. So, along this line yang pink ni, okay, so maksudnya attraction boleh berlaku antara dua pentane. Okay, lagi besar contact surface area untuk berlakunya attraction tu, lagi kuat lah attraction tu. Okay, and then kalau kita tengok benda yang ini pula, this is isopentane, this is isopentane, isopentane. So since the structure dah ada branch sikit, so area, contact surface area untuk berlakunya attraction tu makin kecil. So kita kata attraction tu lemah sikit lah. Okay, and since this one dia punya structure is the shortest and paling banyak branch, so dia punya area of contact surface area pun makin pendek. So area untuk berlakunya attraction tu pun sikit sahaja. So dia ada weakest attraction. Attraction dia paling lemah. Okay, so key dia dekat sini adalah long and linear molecule ada greater contact surface area and stronger attraction. Tapi short and branch molecule ada small contact surface area and weak attraction. Okay, so long and linear molecule can also lie closer together. Okay, so these attraction are at their most effective if the molecules are close. Okay, so long and linear, dia long and linear, dia tak banyak branch tau. So kamu pentane dengan pentane ni dia boleh duduk dekat antara satu sama lain. Tapi kalau untuk benda yang dah start ada branch, dia tak boleh nak duduk close together sangat sebab dia branch tu menghalang dia untuk duduk dia close together. The same for this one, dia tak boleh duduk dekat-dekat sebab branch tu menghalang. Okay, tapi apa signifikannya kalau molekul tu boleh duduk dekat-dekat? So dekat sini dia kata attraction are at their most effective is the molecule are close. That means kalau lagi dekat molekul pentane and pentane tu, lagi kuatlah attraction dia. Okay, macam magnet lah. If you place the magnet close together, dia akan tertarik lah dengan kuat. Tapi kalau kamu letak dia jauh-jauh, tarikan dia sikit-sikit je dapat dirasai. Okay, so itu konsep dia dekat sini. And important here, long and linear molecule have stronger dispersion forces or van der Waals forces than short and branch molecule. Ya, betul. And that is the reason why bila long and linear molecule ada stronger dispersion forces, that means attraction dekat sini kuat. So, boiling point dia pun akan paling tinggi lah compared to isopentane dengan neopentane. Okay, sebabnya when the attraction is strong, kamu kena boleh bayangkan. So, sini let's say lah strong attraction. So, bila strong attraction, you want to break the bond between pentane and pentane sebab itu boiling kan. Okay, so nak break the bond, you will need more heat. Ataupun kita tak tulis more heat energy lah. Kita akan tulis more energy is required. Okay, so more energy is required to overcome the attraction. Okay, so since more energy is required to overcome the attraction, that means boiling point kita akan makin meningkat. Okay. Right, so dekat bawah ni ada another example. Okay, so ini lebih clear because you can see structure tu macam mana carbon and hydrogen tu tersusun. Okay, so ini butane. Okay, kalau pentane 5 carbon, butane 4 carbon. C4 and then hydrogen dia kamu boleh kira lah 3, 2, 3 tambah 2, 5, 5 tambah 2, 7, 7 tambah 2, 7 tambah 3, 10. So, C4H10. Okay, kalau 2-methyl propane, so 2-methyl propane, 1, 2, 3, 4. Bilangan karbon dia masih 4. Hydrogen dia 3, 6, 9, 10. Okay, so C4H10 juga. So, from here, we know that dia punya molecular weight. Molecular weight dia sepatutnya sama, same molecular weight. So, bila same molecular weight, that means kita nak determine strength of van der Waals forces, kita kena jump to the second factor iaitu shape. So, shape saya dah draw dekat sini. Okay, ini long and linear. This one short and branch. Okay, and the boiling point pun dia dah bagi. Boiling point untuk butane negative 0.5. Boiling point for 2-methyl propane adalah negative 11.7. So, this boiling point untuk butane is higher than boiling point for 2-methyl propane. Okay, so kenapa dia higher? Okay, sebab kita gunalah explanation kita tadi. Okay, butane has higher boiling point because it has, okay, butane ada apa ni? Since dia long and linear, that means butane has greater contact surface area. And then, since greater contact surface area, that means attraction antara butane dengan another butane tu, attraction dia sangat kuat lah, jadi kuat lah. Okay, so kita tulis sini stronger dispersion forces or van der Waals forces. So, since dispersion forces between butane dengan butane tu very strong, that means more energy is needed to overcome the force of attraction. So, that's why butane has higher boiling point. Okay, so kalau soalan minta explanation, make sure you have this point here. Right, so the last factors affecting the strength of van der Waals forces is molecular polarity. Tapi saya ingatkan lagi, let's say kamu ada dua molekul A and B and you want to compare which molecule have stronger van der Waals forces. First kamu tengok molecular weight dia. Okay, so molecular weight dia dia kata sama. Okay, so bila sama, then we need to look at the second factor iaitu molecular shape. Okay, so let's say lah the molecular shape sama. Contoh dua-dua ni long and linear. So we cannot compare in terms of shape. Kita kena tengok pula molecular polarity. So kita tengok molecular polarity. So the boiling point of C2H6 and CH3F are, okay, so kita tengok from this table, in C2H6 is ethane, in fluoromethane. So molar mass dia tak jauh beza, 30 and 34, tapi polarity dia berbeza. Ethane is non-polar while fluoromethane is polar molecule, and we need to look at the boiling point. So the boiling point, obviously untuk polar molecule the boiling point is higher. Okay, so both molecules have almost similar molecular mass. The boiling point of CH3F is higher than ethane as CH3F is polar but C2H6 is non-polar. Okay, so kita kena ingat balik lah tadi awal-awal kita ada belajar. Okay, kalau dia polar, that means bonding yang exist antara CH3F dengan another CH3F adalah dipole-dipole forces. Okay, and then kalau dia non-polar pula, that means bonding yang exist between ethane dengan ethane adalah London dispersion forces. Okay, so between London dispersion forces dengan dipole-dipole forces, kita tahulah, saya dah tunjuk awal-awal, dipole-dipole forces is stronger than London dispersion forces. So that's why the boiling point for fluoromethane is higher than ethane. Okay, so important, for molecule of similar molecular weight, polar molecule have higher boiling point due to stronger dipole-dipole interaction. Okay, kalau dia ada molecular weight yang almost similar, macam ni lah 30 dengan 34, so kita boleh assume dia ada similar molecular weight. So polar molecule ni akan ada boiling point yang lagi tinggi disebabkan dia ada stronger dipole-dipole interaction. Okay, so macam mana kita nak tahu molar mass tu similar or not? Okay, so dekat bawah ni, if the molar mass difference is more than 10, dispersion forces will dominate the dipole-dipole forces. Okay, dia ada syarat dia. Macam mana similar molar mass tu maksudnya? Similar molar mass ataupun molecular weight tu, kita cakap apabila perbezaan dia less than 10. The difference is less than 10. Macam ni lah, 30 dengan 34, the difference is 4. Beza dia 4. So, bila beza dia 4, that means dia less than 10. So, kita assume this molar mass is similar. Okay. Kalau 30 dengan 38 pun still similar. Sebab beza dia baru 8. Okay. And then, tapi what happen kalau dia punya difference more than 10? Okay. So, let's say kita ada satu molecule 30. Another molecule is 50 gram per mole. Okay, so dalam keadaan ni, kita assume dia punya molar mass dia difference. So, bila molar mass dia difference, so kita kena tengok balik to the first factor lah. Okay, kita kena tengok balik the first factor iaitu ini, molecular size. Kalau molecular size dia besar, that means stronger intermolecular forces. Okay. Alright, so dia kata kalau molar mass difference is more than 10, dispersion forces iaitu London dispersion forces akan dominate dipole-dipole forces. Alright, so to test your understanding, kamu faham ke tak about the factors affecting van der Waals forces, kita cuba example ni. So example ni dia kata, which compound has a higher boiling point? Trichloromethane atau tetrachloromethane. Okay, so first kita tengok structure ni. Okay, so from this drawing, we know that the shape dia sama lah. Okay, tapi okay, you cannot jump to shape terus. Kita kena tengok satu-satu. Start from molecular weight. Okay, So, molecular weight saya dah tolong kira dekat kamu. So, the molecular weight for CHCl3 adalah 118.5 gram per mole, while molecular weight for CCl4 adalah 154 gram per mole. Okay, so obviously molecular weight dia more than 10 perbezaan dia. Okay, lebih daripada 10. And this tetrachloromethane has higher molecular weight. So, bila dia higher molecular weight, that means dia punya attractive forces should be stronger in between CCl4 molecule. So, maksudnya kita boleh cakap CCl4 ada higher boiling point. Okay, so tempat kosong sini adalah CCl4 has higher boiling point because it has bigger molecule with more electron, ataupun it has bigger molecule with high molecular weight pun boleh. Okay, the increase in the London dispersion forces, tempat kosong, the dipole-dipole forces. So, kiranya bila the difference, okay, atas ni pun ada, molar mass difference is more than 10, that means dispersion forces will dominate the dipole-dipole forces. So, tempat kosong sini adalah dominate. Okay, so the increase in London dispersion forces dominate the dipole-dipole interaction. So, more energy is needed to overcome the attraction. Okay, so please cross out dipole-dipole forces ni. Saya tersalah tulis. Okay, so dekat sini sajalah saya tulis benda-benda ni untuk distract kamu. Okay, so sebabnya ada student, dia bila tengok soalan ni, dia terus tengok kepada mu semua ni. Dia tengok, oh, ini non-polar, ini polar. So, obviously polar will have higher boiling point. Tapi saya cakap, kita kena tengok step by step. Tak boleh terus jump to the molecular polarity, tak boleh. Kena tengok molecular weight dulu. Okay. So, since molecular weight dia different, that means kita akan stop dekat situ lah. Okay. Molecular weight yang lagi besar ada stronger van der Waals forces. So, that's why CCl4 is the molecule yang ada higher boiling point compared to CHCl3. Okay. So, hopefully it makes sense to you. Okay. Alright, next conclusion. Okay, so kita dah nak habis. Polar molecule have both London dispersion forces and dipole-dipole forces. Betul. Untuk polar molecule, dia ada dipole-dipole forces yang lebih penting lah. Tapi, don't forget, dia juga ada London dispersion forces. Sebab London dispersion forces wujud dalam semua atoms dan molekul yang ada dalam muka bumi ni. Okay, so non-polar molecule possess London dispersion forces only. Tapi untuk non-polar molecule, dengan non-polar molecule, dia hanya ada London dispersion forces sahaja. Okay, so the stronger the van der Waals forces, the higher the boiling point. Ini kita tahulah sebab lagi kuat attraction antara molekul tu, lagi susah kita nak break the bond. So, nak break the bonding. So, bila susah nak break the bonding, higher boiling point as it require more energy to overcome the attractive forces. Okay. So, settle untuk factors affecting van der Waals forces.